All right, let's go on a bit of an impossible journey, shall we? It's a thought experiment, really. One that's going to take us all the way to the edge of the universe just to try and wrap our heads around one simple question. Imagine, just for a second, that we could build a spaceship that travels 1 light-year every single second. Now, just to be clear, that's not the speed of light, that's a light-year of distance, covered in a single second. So if we had a ship that fast, where could we actually go?
Just to give you an idea of how fast that is, light itself travels at an incredible 300,000 kilometers per second. I mean, it can zip around the Earth 7 times in the blink of an eye. But out in the vastness of space, even that is a total snail's pace. So our ship's impossible speed is really just a tool, a way for our minds to even start to grasp the true, mind-boggling scale of the cosmos.
Okay, you ready? Buckle up. The clock starts now. Our first few stops are going to be right here in our own cosmic backyard. And just like that, 4 seconds. 4 seconds into our trip and we've already arrived at the Alpha Centauri system. That's our closest stellar neighbor, about 4.22 light-years from home. If that sounds familiar, it's actually the exact place humanity was trying to get to in the sci-fi epic The Wandering Earth. But here's the kicker. It only took us 4 seconds. A real-world journey with our current tech, we're talking 2,500 years. And that right there is our first taste of cosmic scale.
Let's keep this thing moving. At the 8-second mark, we zoom right past Sirius. You've probably seen it. Look up on a clear night. It's that brilliant blue-white star, the brightest one in our whole sky.
Okay, now we're going to fast forward a bit. 10 full minutes into our trip, we are now approaching one of the most exciting exoplanets ever found, especially when it comes to the hunt for life, Kepler-22b.
This thing is what they call a super-Earth, about 2.5 times the size of our own planet. And because it's sitting perfectly in the habitable zone of its star, scientists think it's one of the best places to look for advanced extraterrestrial life.
5 hours pass, and we arrive at an absolute monster of the cosmos. This is Stephenson 218, and it is the largest known star in the entire universe.
I mean, try to wrap your head around this. If you drop this star into the center of our solar system, its edge would stretch out past the orbit of Saturn. You could fit 10 billion of our suns on its surface. It's a scale that's almost impossible to even imagine.
So far, everything we've seen, believe it or not, has been pretty local. But now, it's time to take a much, much bigger step. We are leaving the Milky Way.
After flying for a full 24 hours straight, we finally crossed the boundary of our home galaxy. And for the very first time, we can turn around and see it all. That entire magnificent spiral of the Milky Way just hanging there in the dark. But even this is just the beginning.
We travel now for 1 continuous month, no stops. And at the end of that month, we arrive at our closest major galactic neighbor, the incredible Andromeda Galaxy.
And if you thought our galaxy was big, well, Andromeda just blows it out of the water. It's got a diameter of 220,000 light-years and holds over 1 trillion stars. Compare that to the Milky Way, which has maybe 100 to 400 billion. Andromeda is a whole other level of city of stars.
So, we've visited stars, and we've hopped between galaxies, but what's next? What's the next level up? Well, we're about to enter the realm of cosmic superstructures.
So get this entire trip we've been on, from Earth, past Sirius, all the way to Andromeda, has been inside one single structure called the Local Group. It's this cluster of over 50 galaxies, all bound together by gravity, and it stretches across a staggering 10 million light-years.
Okay, now for a serious jump. We push on. For 16 years, we fly. 16 years at a light-year per second, until we finally reach the edge of something even grander, the Laniakea supercluster.
And this is where this scale just becomes, well, it gets ridiculous. Our Milky Way is just one of about 50 galaxies in the Local Group, but the Laniakea supercluster? It contains our Local Group and around 100,000 other galaxies. It's 520 million light-years across.
From this far out, our entire home galaxy, everything we've ever known, every star we've ever seen, is just a single, insignificant point of light among 100,000 others. It's humbling.
We've been at this for years. We've crossed galaxies and superclusters. Now it's time for the final leg of our journey, to the very limits of what humanity can see.
After flying for more than 1,400 years, we're here. We finally reached our destination, the boundary of the observable universe.
We are now 46.5 billion light-years from Earth. This is it. This is as far as light has had time to travel to reach us since the Big Bang. We've literally reached the edge of the map.
But hang on, is this the real edge of the universe? The answer, according to pretty much all physicists, is almost certainly no. This is just the edge of what we can see. Beyond this boundary, the universe itself likely just keeps on going, maybe forever.
And that's what this whole journey really leaves us with, doesn't it? This final, humbling thought. Even traveling at the impossible speed of 1 light-year every single second for over 1,000 years, we still couldn't reach the true edge. It's a journey that shows us, in the most profound way you can imagine, just how incredibly small we really are.